Hi, I'm Maya Schoenberg. I'm a master's student with the University of Northern British Columbia over in Canada. I'm here with the Okuda Lab as part of a summer internship through the MITAX and Japanese Society for the Promotion of Science internship program. My research while I'm here at Keio University is to look at the chemical composition of subweight PM2.5 and see how it affects our lung cells. PM2.5 is basically a term used to describe particulates that are in the air that have a diameter of less than 2.5 micrometers. Its small diameter allows it to penetrate deeply into our lungs, so this can cause increased respiratory irritation, lung cancer, sinonasal cancer, or asthma. PM2.5 in subway stations is of increasing concern in Japan. In your subway stations, everything is trapped, right? So we have an increase in particulate matter that can't escape. And then every time the train comes by, there's wear and tear on the tracks and the brake systems of the trains. So this can cause increased levels of iron, copper, chromium, and manganese to be found in this PM2.5. So as part of my experiment, we're working with A549, so lung cancer cells. So all of my cells are in there. But since these cells are living, so what we do is it's called cell culture. So this is our sample here, and if you look down at the bottom, you'll see what looks like white powder. So those are the cells. What we want to do is remove this solution and then put it only in medium. So in order to determine how many cells are alive and how many are dead, we use some blue dye. So I'm basically mixing these together, and then we put them on a microplate reader. So we take the cells that we've grown and we've cultured, and we put them into 96 well plates. And we basically dissolve our vanishing filter into some of that medium that we were using earlier and add it into the wells. Then we load it into the microplate reader. So my research back in Canada has mainly focused on environmental and indoor or workplace air quality. So I've primarily been doing chemical composition analysis, as well as looking at different organic compounds that might be present in the particulate matter. But one of the aspects I really wanted to learn more about was how does the composition affect us? So I joined the Okuda Lab because I wanted to learn more about cell viability studies and kind of what's going on in the subway stations in Japan. My time with the Okuda Lab has been amazing. Everyone has been so kind and welcoming, and it's really neat that everyone is in the same office. From your bachelor students, your masters, to your postdocs, and your supervisor, they're all like right next to each other and actively communicating. So it's never just your problem, it's our problem or our challenge that we have to fix or overcome. So that's one of the main things that I'm really enjoying about the Okuda Lab. So in terms of the culture in Japan, one of the main things that stands out is the food. There are so many different varieties of food that I've never experienced before, but so far I've found that I really like the okonomiyaki, and I also tried sushi for the first time with the Okuda Lab at my lab introduction. So that was a neat experience because back home I don't normally like fish, but here it's just done so well and it's so delicious so far. Other things that I've enjoyed is I participated in a homestay program with a family down in Yokohama, and we went to Sankin Garden and we fed the koi fish and the turtles. Like that's something that I've never gotten to experience in Canada, and it was so much fun. Well, my first goal after the program is to finish my master's thesis. When I go back home, I'm going to go back to the university and basically communicate some of the things I've learned, because the whole cell viability stuff is new to our lab. So we'd like to find ways to kind of collaborate with the Okuda lab and basically share this research and find different areas to grow into, because we have a lot of unique opportunity over in Prince George, where we have like a wildfire season and a road dust season. So I think it'd be really neat to kind of keep continuing to look at those effects and look at the chemical composition as well as the cell viability. So that's one of the main things I want to bring back to my lab, is just some of the principles I've learned here and some of the workplace culture as well.